45 RPM is turned off, it comes to rest in 15 seconds. Find A, the angular acceleration, the average angular velocity of the turntable, and the number of revolutions it makes before stopping. A similar kind of problem. What do we have? The turntable is rotating at 45 RPM. That is, the initial angular velocity is 45 RPM. Convert that to radian per second. What do? Multiply by 2 pi and divide by 60. That will be 45 multiplied by 2 pi radians divided by 60 seconds. That is 4.7 radian per second. And what's omega f? What is the final angular velocity? Is 0. It is brought to a stop. And it happened in a time t equal to 15 seconds. Therefore, angular acceleration is omega f minus omega 0 divided by delta t. That is 0 minus 4.7 radian divided by 15 seconds. That is negative 0.31 radian per second squared. When a rotating disk comes to a stop, its angular acceleration is negative. What is the average angular velocity of the turntable? How do you find the average velocity? If you know the initial velocity, and the final velocity, the average velocity is the final velocity plus the initial velocity divided by 2. That will be 4.7 radian per second plus 0 divided by 2. That is 2.35 radian per second is the average velocity during that time. And now, what is the number of revolutions it makes before stopping? Well, to find the number of revolutions, you need to find the angular displacement. How do you find the angular displacement? Well, theta equal to theta 0 plus omega 0 t plus 1/2 alpha t squared. Theta 0 is 0. Omega 0 is 4.7 radian per second. And alpha we calculated, I didn't carry it here, but we have that value in the previous slide. Well, so omega 0 is 0. Theta 0 is 0. Omega 0 is 4.7 radian per second times t is 15 seconds plus 1/2 alpha. We calculated the angular acceleration as negative 0.31 radian per second squared times t squared is 15 squared. Calculate this on your own on your calculator. That should give you 35.6 radians. The angular displacement of the disk in coming to a stop is 35.6 radians. Now, this 35.6 radians correspond to how many revolutions? Each revolution is 2 pi radians. Therefore, the number of revolutions in coming to a stop will be this divided by 2 pi. So number of revolutions is theta divided by 2 pi. That is 35.6 divided by 2 pi, and that is 5.7. The disk did 5.7 revolutions in coming to a stop. Another one. Starting from rest, a disk takes 10 revolutions to reach an angular velocity of 8 pi radian per second. How many additional revolutions are required for the disk to double its angular velocity to 16 pi radian per second? Now understand this problem very well. Read it one more time. We have a disk is starting from rest and it takes 10 revolutions to reach this angular velocity 8 pi radian per second. Now 10 revolutions means how many radians? 20 pi radians. Now the question is, how many additional revolutions are required for the disk to double its angular velocity to 16 pi radians? Alright, what do? First we find the angular acceleration alpha using the first situation. Now what are the data there? We have omega 0 equal to 0. The disk starts from rest and it acquires an angular velocity of 8 pi radians, omega f equal to 8 pi radians. In describing an angle, how much angles? 10 revolutions is 10 times 2 pi radians. That is 62.83 radians. So look at that data once again. A disk starts from rest and in rotating through an angular displacement of 62.83 radian, it attains a final angular velocity of 8 pi radians per second. So we have the initial angular velocity, final angular velocity, and the angular displacement. Can you use these values to find the angular acceleration? What is the equation you will use for that? Remember, the equation you will be using will be the one that does not contain time. Alright? We use the equation omega f squared equal to omega 0 squared plus 2 alpha theta. That will be omega f is 8 pi. 8 pi squared is omega 0 is 0 plus 2 alpha theta. Theta is 62.8. And you can now solve for alpha from here. I'm going to leave it for you to do that on your own. I got alpha equal to 5.03 radian per second squared. And now, what you need to understand is that the angular acceleration is not changing. This angular acceleration is a constant. So, we need to now find how many additional revolutions. In order to do that, we will find the total angular displacement for it to reach that final angular velocity. So, for the next part, what is for the next part? In the next part, our final angular velocity is 16 pi radian per second. The initial angular velocity, you see, we have now completed the first part. The disk has an angular velocity of 8 pi radian per second. Now from 8 pi, its angular velocity is going to increase to 16 pi. So we will say omega 0 is 8 pi, omega f is 16 pi, and angular acceleration is 5.03 radian per second squared. We got the initial angular velocity, final angular velocity, and alpha. Can you find the angular displacement during that second part? Yes, we can find the angular displacement using the same equation. Omega f squared equal to omega 0 squared plus 2 alpha theta. Well, replace these values. That will be 16 pi all squared equal to 8 pi all squared plus 2 alpha theta. We can now solve for theta. And solving for theta gives, I want you to do this on your own. It will be this quantity minus this. Evaluate that first. And then divide it by 2 times 5.03. and that gives me theta equal to 188.4 radian. Now this is the additional angular displacement from 8 pi radian per second to 16 pi radian per second, and we want to find how many additional revolutions. 188.4 radian correspond to how many revolutions? So the additional revolutions will be this radians divided by 2 pi, and that is 30 additional revolutions. So in 30 additional revolutions, the angular velocity will become double the value. Another example. A Ferris wheel of radius 12 meter rotates once in 35 seconds. It goes round once in 35 seconds. What is its angular velocity in radian per second? What is the linear speed of a passenger? What is the centripetal acceleration of a passenger? Well, here is the Ferris wheel. You are familiar with this. The radius is 12 meter, that's that distance, and passengers are sitting at the edge. Means the distance of a passenger from the center is 12 meter. And the period is 35 seconds. The time taken to go round once is 35 seconds. Well, you know that omega equal to 2 pi divided by the period. Now look at that equation, how handy that is. The angular velocity is 2 pi divided by the period. That is 2 pi divided by 35 seconds. That is 0.18 radian per second. So you can see the first part is so simple. How about the second part? What is the linear speed of a passenger? If a passenger is sitting here, the linear speed is the same as the tangential speed, v equal to r omega, where r is 12 meter, omega is 0.18 radian per second, and that will be 2.16 meter per second. And the next one, what is the centripetal acceleration? Do you remember the equation for centripetal acceleration? We have that equation using linear speed and also the angular velocity. Well, the centripetal acceleration is given by A equal to V squared over R. We just calculated V. That will be 2.16 squared over 12. That is 0.39 meter per second squared. And that is the linear, the centripetal acceleration of the passenger. That means the passenger will be experiencing a force towards the center with this acceleration. Well, I think what we have, well, why not do one more problem before we close the lesson? A bicycle wheel has a diameter of 1.2 meter. The bicycle accelerates from rest to a velocity of 22 km per hour in 10 seconds. A. What is the angular acceleration of the bicycle? B. What is the number of revolutions of the wheel during this time? And C. What is the distance traveled by the cycle during this time? Well, all these we have actually done already. This is a recap of what we have already done. Now I have a fancy bicycle wheel here. What is given to us? The diameter of the wheel is 1.2 meter, means the radius of the wheel is 0.6 meter. The initial